Hello all. In this lesson we're going to be studying our second day of functional groups, and we're going to cover a lot more ground today. We're going to discuss aldehydes, ketones, ethers, and organic acids. So when we finish talking about organic acids, we will have done halides, alcohols, ethers, aldehydes, ketones, and organic acids. We'll still have to talk about esters, amines, and amides to some extent, but those will come in the next lesson. The bookwork that's associated with this lesson is listed here. You need to be doing questions 36, 38, 40, 43, 44, 46, and 48 on pages 204 to 206. We'll also have a few questions just for studying down here on pages 203 to 204. And the aim that I want you to copy down is what are aldehydes, ketones, ethers, and organic acids. And follow that up with these three do-now questions, which we'll solve in class. All right, aldehydes are first up. So aldehydes are right here on your table R. So this is the information that you would be given. But I'm just going to copy down the condensed structural formula for propanal because we'll need it here. So first question on this slide is to locate the entry for aldehydes and describe the aldehyde or the carbonyl functional group. I do want you guys to think of aldehydes as also being carbonyls, even though the regions don't typically use this term. They typically only say aldehyde. And I just think that's a good idea because in college it could be either one. But in any case, the way I would describe this is that you have a carbon with a double bonded oxygen, and you have a hydrogen attachment, and otherwise it's bonded to something called an R group, and the R group is just the rest of the molecule, like the parent chain. And what I want to do here is I want to translate the condensed structural formula into a structural formula. So I'll do that now, bit by bit. The CH3 would really be this. And the CH2 would be that. The C double bonded O would look like that. And then you have the H attachment. And we're all good. Now this is called propanal. So that means that the way they basically named this was they named the carbon backbone, and that's how they got the propan part of the name. And they ended it with the suffix Al. And the reason for doing that is because this attachment, the C double bonded O, is characteristic of aldehydes along with the H. So the C double bonded O with the H is going to be aldehyde, so it gets ended in an Al. Now we will never have to use numbers to locate the position of the carbonyl group. I'm going to highlight the word carbonyl again because I really want you guys to remember it. But we'll never need numbers to highlight the position of the carbonyl because look how many bonds are in a carbonyl. This carbon has 2 bonds to oxygen and the third bonds to hydrogen, which means it has only 1 bond left over. And if you only have 1 bond left over, the best thing you can do is to hang on to the end of a molecule. In other words, the carbonyl will always be at the end of a molecule, or it'll always be at position 1, and therefore it doesn't need an address. So let's name this molecule right here. First step is let's name the parent. It has 1 carbon, so we'll call it methane. And the second step is to recognize that we have a C double bonded O with an H, and whenever that happens, you have an aldehyde on your hands. So this is indicating aldehyde, and we're going to end it as methanal. Interesting note, pronunciation really matters for this because a lot of students would say methanol, which would be a different molecule, which is an alcohol. It's what we studied yesterday. So the methanal, you really do need to pronounce that A as a short A. Okay, so ketones are up next. So let's check out table R. So this is what table R has for ketones, and here's the condensed structural formula of their example. But it's sort of like an aldehyde, except that a ketone has an R with a C and a double bonded O, and another R group. So instead of having an H here, it has another R. You can see that reflected up here as well. So in other words, I would just say a ketone is more in the middle of a molecule, whereas an aldehyde would have to be on the end. So let's take this condensed structural formula and translate it into a structural formula. So I'll do the CH3 first. That's obviously going to be that. Then we have a C double bonded O, which is here now. Then we have a CH2. And another CH2. And a CH3. And this is what they're calling 2-pentanone. So let's split this up into the things and what they mean. So first of all, the pentan part of the name is coming from the 5-carbon backbone. 1, 2, 3, 4, 5. The number 2 part of the name is coming from the fact that the double bonded O is on carbon number 2 if you count in from the left-hand side. And the "one" part of the name is coming from the fact that you have a double bonded O, making it a ketone. So those are the 3 parts of the name, and I can write that in for how ketones are named. All right, let's use these general rules to name these 2 molecules. First up is this guy who has 1, 2, 3 carbons. So we'll start out with the propan as part of our name. This is a ketone, and I can tell because the double bonded O is in the middle of this backbone. So I will end this name with "one." So it's going to be some kind of propanone. And it is on carbon number 2. However, I suggest not putting a 2 in front of the name, so don't do this. And the reason I would say don't do it is because basically if a ketone has to be in the middle of the molecule and a 3-carbon molecule has only 1 middle, then this is the only place it could be, which means I think that you don't need to put a number in. Now let's try the next one. We have 1, 2, 3, 4 carbons. So butan is going to be part of our name. And it does have a ketone attachment with the double bonded O in the middle of the molecule. So we will end this in "one," so it's going to be a kind of butanone. And if I number from the right and go left, we have carbon 1 and carbon 2. And if I number from the right, it ends up on carbon 3. However, I wanted to point one other thing out, which is that if you flipped this molecule around, the double bonded O would land here, which would still be named 2-butanone because it would still be on carbon 2 if it landed here. And it can't be on the ends because that's an aldehyde. It can only be at one of these 2 carbons, and both of these carbons would be considered carbon number 2. So my suggestion, again, is actually not to write 2-butanone because I think there's only one kind of butanone, and it's either going to be here or here, but those are the same location. All right, ethers. Let me show you ethers on table R. So here they are. It's basically just going to say RO, R prime, and here's our example, but we'll do that later. For now, let's just describe this functional group. It has a parent on the left and a parent on the right, and in the middle it has this oxygen bridge. That's what I call it anyway. So let's take the condensed structural formula they're offering us and translate that into a structural formula. So here's the CH3. Here's our oxygen bridge. Our CH2. And we need another CH3. So they called this methyl ethyl ether. And essentially what they have done to make that happen is they named the R group, which could be either side, but I chose that to be R. So we say methyl for that part. And the ethyl is coming from the other side, so it's the 2-carbon ethyl group. And the ether part of the name is coming from the oxygen bridge. And you don't need to locate it because it'll be in the middle between the 2 R's. So how are ethers named? Name R prime, and add the word ether. So let's use those rules to name this molecule. So I would say that we should name the R group first. So here's our R group. That's going to be ethyl. Now let's name R prime. It's right here. It's also going to be named ethyl. And then let's name the functional group, which is an ether functional group. And we'll add the word ether. So while the Regents don't mind which way you do this, you can say ethyl ethyl ether for this name, that's totally fine. Or you could also call it diethyl ether, just applying a prefix to the ethyl to say that there are two ethyls in this ether, and everybody would know what you were talking about. And the last functional group we're studying today is organic acids. I'm going to show you the portion on table R for that. So there it is, and you can also see an idea of it here. And basically you have a parent chain which has a carbon, and that carbon is double bonded to an O, but then it's bonded to a hydroxyl group as well. It reminds me of an aldehyde, except an aldehyde had just an H here, and this has an OH. So let's take this information and this structural formula and convert it into a structural formula. So CH3 is first, followed by a CH2, followed by a C double bonded O, and an OH. Cross all that out. And they are calling this one propanoic acid. All right, so the carbon backbone with 3 carbons gives us the basic name propan. But the organic acid attachment, which is the double bonded O and the OH, is what gives us the ending, which is oic acid. So it's all of that gives you the oic acid ending. We don't need a number for any of these. And the reason why you'll never need a number is that I'll come up here. So this carbon has 1 bond to the parent chain, and 2 bonds to the O, and 1 bond to the OH. So it has 1, 2, 3, 4 bonds that are required, and that means there are no bonds left, and there's only one place it can be. It can only be at the end of a molecule, and it will always be position 1. And lastly, I just want to name a couple more examples. So this one is a 1-carbon molecule, and we have the double bonded O and an OH. So the 1 carbon is going to give me the beginning methane, and the O and the OH are going to give me the ending oic acid. All right, now for the next one, we have a 1, 2, 3, 4, 5. We have a 5-carbon parent, so that's going to be pentan. And the C double bonded O, OH, gives us the ending oic acid. And with that, we've reached our pair-up. So please copy down these questions and have them ready to answer in class next time I see you. And follow up with these summary questions. Of course, you don't need to copy down the diagram, but please do read this little cartoon. This is from an actual Curious George story, believe it or not, and we'll answer these questions in class. And that's it. I hope you learned something, and thanks for watching.